Now we are going to discuss about a simply supported beam with one side overhang with UDL. Same as previously, we are taking moment about point A, RB into distance between two supports, that is RB into L, RB into 3 equals to downward moment, downward load into distance. Here downward load is equal to 4.5 into 3 plus 1, 4 meter, into that the distance from CG, that is 2. It's being like 4.5 multiplied by 4 multiplied by 2. From there we may get RB equals to 12 kilonewton, and from the rules we know RA plus RB is equals to 4.5 into 4. So RA equals to 6 kilonewton. Now we will go for shear force diagram. First of all, shear force at point C will be 0, and from C towards B point it's being negative for UDL and going downwards, straight line. Previously we have done the shear force diagram for UDL. Here also same diagram rules, but shape of diagram will be same that previously. So for the downward load it's going to straight line and downward from C point to B point. At the B point it will be the value of 4.5 into 1, that is 4.5 kilonewton, and at the B point we know that upward reaction force equals to 12 kilonewton, so it's going up towards, that is 7.5 kilonewton from baseline towards upward. Then again it will go downward for existing UDL, and the value at the A point will be 4.5 into 3, and the value at the A point will be 6 kilonewton equals to RA value. Now we will draw the bending moment diagram. For the point C, the bending moment value will be 0 because of there is no distance. And now we will go for B point. There is a bending moment of value negative 4.5 into 1 into 0.5, that is minus 2.25 kilonewton. And again at the point A, the value of bending moment will be 4.5 multiplied by 4 multiplied by 2, and positive value of RB, that is 12 kilonewton, and the bending moment at A will be 0 also. Now we have to calculate at that point where shear force changes its sign, taking that point as M. Now at the point M the shear force will be 0. First of all we are taking the distance M to B equals to X. Then from two triangles of shear force diagrams we may write down 6 by 3 minus x equals to 7.5 by x. From there we may get the value of x equals to 1.67. Now we are calculating the bending moment at the point M. That would be negative 4.5 into 1.67 plus 1 into 2.67 divided by 2, and positive value of RB, that is 12, into x, mean 1.67, and the value of M, bending moment of point M, will be 4. Now we may consider the point P is a y distance away from the point A, and at that point as bending moment equals to 0, then whole equation will be equals to 0. From there we will find out the value of y, means the distance of point of contact flexure from the point A. Now bending moment at the point P, that would be RA into y minus 4.5 into y by 2 equals to 0. We may write from this equation we may get y is equal to 2.67 meter. Here we are calculating from point A. Instead of all other calculations was happen from the point B. In that case, if we calculate from point B, the calculation will be complicated. So for your help I am calculating this from A point. So the point of contact flexure would be 2.67 meter away from the support A.